20 point.
Good evening, sir.
Good evening, sir.
Hotel volume and camera. वार्मिंग मिल गया वार्मिंग मिल गया कितना 8,000 रुपये PTC और टैक्सेस
Hello, good evening.
Sir, good evening, sir. Sorry.
Okay,
Good evening, sir.
no issue, no issue. So we'll
Start, sir.
share, yeah, we'll start the class. Let me share the screen. Okay, where we stopped previously yesterday? I think somewhere.
Parallel hybrid actually.
Yeah, parallel library we talked, correct? Parallel library talk. Yeah, thank you. Okay, now we'll continue with that. So parallel library. Let me make it full screen. Okay. So parallel hybrid, because parallel hybrid name itself says that there are two energy sources or power sources which is going to drive the vehicle. One is the electric motor, other one is engine. Engine gets its energy from fuel. It can be petrol engine, diesel engine, or a gas engine, LPG, whatever. Other one is electric battery. From battery, power is given to the converter. Already explained. Depending on type of the motor, whether it is a AC motor or a DC motor, the converter, there were two type of converters. One is called DC to DC converter, note down. Other one is DC to AC converter. Other name for this AC converter, DC to AC converter is called inverter. Whenever somebody says is inverter, that means it takes power from your battery, which is a DC power, that is converted into AC power. Where DC power means constant voltage with respect to time. This is voltage from battery. It can be 12 volt, 24 volt, 100 volt, 600 volt, water depending on battery package, this one. And it is converted to AC voltage, which is time varying. It can be 100, 200, 300. If the motor is a AC motor, if it is using AC motor, then the DC voltage will be converted to AC motor and it will be supplied to AC motor. Instead of that, if you have a DC motor, then from battery, you will have DC to DC converter. As I told yesterday, the battery voltage may be low or high compared to the DC motor voltage. Then the voltage will be amplified to required level, that is done by DC to DC converter. Then finally, we know that the motor generates the mechanical torque. Here is the electric power is the input. Electric power is input to the motor. Then motor generates mechanical power which is going to drive the vehicle or wheels through the transmission system. Simultaneously, you have your engine. It can be diesel or petrol engine, and it will be supplied with the type of fuel what is required. Then it generates a mechanical power. Please note that you have both. In the figure clearly shows that both are providing mechanical power. Correct? Mechanical power. Here also mechanical power. That means simultaneously can get another. So simultaneously, both engine and power electric motor can give to drive the wheel. How it does, depending upon the situation. We are going to see modes of driving of series hybrid and parallel hybrid in subsequent slide. So both internal combustion engine and electric motor will be connected to the wheels through the proper gear box and clutch mechanism, all those things. Then the two power sources are connected to through proper gears. The torque supplied, basically, mechanical power means basically torque multiplied by speed is called power. We know that power is a secondary quantity. The actual engine generates only torque. Correct? If the torque is able to overcome the frictional and inertial forces, then this the engine start rotating, which is connected to gearbox. The wheel start moving, and on the wheel, the vehicle load is passenger plus vehicle load is acting, and there's a friction between wheel and the road surface. We call it a traction. Correct? The traction. So the tractive force is generated by the engine or by motor, correct, which overcomes the all the friction, correct, engine friction, gearbox friction, transmission friction, and road friction between tire and wheel, right? And then the torque generated is sufficient, then only wheel start moving. So that means engine torque should be greater than the torques required to overcome frictional torques, and which is appearing for a different location. Okay, so the similarly electric motor, we know the rotational force is called as torque. So any rotating this, whether it is a motor or a engine or a jet engine, whichever generates a rotating force, which is called a torque, that is the primary. So generally we say that we talk any rotating, correct, whether motor or engine or gas turbine, we talk in terms of power, so many kilowatts. Correct? We know that power is a secondary quantity. It is N is nothing but speed of the shaft multiplied by torque available at this one. Actually, engine is generating torque only. Correct? Due to that, if it is able to overcome the friction, the shaft start rotating, engine RPM starting from 0 to increasing. If you multiply the both, that is what the engine power we are talking, or motor power. So power is called secondary unit. Primarily, motor generates motor or the engine generates torque only. So if the sufficient torque is supplied and speeds are added up, then vehicles start moving. Then we are able to accelerate. When only in parallel hybrids, at any time you can operate only one power source, whether engine or motor or both together, sharing the load. Okay, and maybe large part torque maybe other it can be done. We'll see that. The third one is
one question, sir, on this. Yeah. So I understand that like the torque that needs to be produced on through the motor and as well as the engine should be the same.
Need not be same.
Need not be the same?
No, need not be. See, in parallel, both are supplying, no? It is added up. See, because there is a torque coming from here, I say T motor, T engine, correct? This plus this is called a T wheel, supplied to T wheel.
Okay.
Torque is getting added up.
Okay, sir. But how it will be like because of the different torque will not be a problem?
No, that's the gear arrangement. You have we are going to talk about how this one. You need a proper mechanism, the gear mechanism, which is going to add up this one. We will see that.
Sir, I have one point to raise here. Few vehicles, especially performance vehicles, if they're parallel hybrids, they sometimes have the front wheels driven by electric motor and the rear wheels driven by ICE power or something of that nature.
No, that's what people are trying different, correct? Different combination they're trying, but you have gear mechanism which can add up, correct? To torque coming in one shaft, another shaft is given to sun gear arrangement. Okay, so that it can add up. I'm going to talk. I will show them. We will see them. Okay, so that's possible. So this how it works. Then third type is called split power or power split. These are two names are synonymally used. It can work. You can see the picture. You have the fuel tank which is going to give fuel to engine. Engine generates torque, T engine, correct? And the engine power can directly go to the wheel. This is a direct path. Engine torque development engine can directly go through the transmission mechanism to the wheel, and also it can go. Some part of the engine torque can be supplied to an electrical generator. Electrical generator will generate electrical power that will be connected to a charger, correct? A charging circuit, because many times the electric generator will be AC generator, no doubt. Previously, you have, because you know the generator, you have DC and as well as AC generator. There are two types of generators. Even now available, AC generators are highly efficient compared to power losses, frictional. There are many advantages compared to AC generator. We call it as alternator. AC generator, other name is called alternator. Other one is a DC generator. Okay, DC generator nowadays generally becoming less and less because of there are a lot of losses in the brush loss. There are so many things, power loss inside the generator itself. Instead of that, AC generators are most preferred. So the AC generator will, if it is there, then the AC generator output voltage is a AC voltage. This cannot be supplied to battery. To charge the battery, you need a DC voltage. But if the generator is AC generator, then that should be converted, rectified into DC voltage. So the charger circuit will have rectifier. What is the job of the rectifier? It converts the AC voltage. If the generator is AC generator, please note that. So don't say that, sir, I saw in some car they say using DC generator. Then I don't need rectifier. But of course, charging circuit will be. What is charging circuit? We need to control the amount of the voltage applied to the battery and also the rate at which current is supplied. They are called charging rate. If you directly connect the generator output, you may overcharge, battery may fail. So you need to control voltage and current. So because what is the rate at which you can charge the battery, that is given by manufacturer. Correct? So many hours, this is the current you need to supply. 2 amps per hour. Correct? 2 amps for 10 hours. Or 5 amps, for example, 4 hours. Something you have to see the battery manufacturer. They say what is charging rate and discharging rate. Specifically, charging rate is very, very important. Sudden discharging also not possible. Battery won't supply. Okay. Charging, you should not overcharge, or too much charging also you cannot do. The rate at which they said that is controlled by charger. So apart from that, if it is a AC generator, you will have a rectifier also. Rectifier circuit plus charging circuit will be connected to generator, AC generator, which convert DC voltage that is supplied to battery. Okay. And then you have the converter. That's what I told you. This depends upon whether it is AC to DC converter. Sorry, it is a DC to AC converter or inverter circuit, or it can be DC to DC converter. Please note again, the generator voltage, what is generated, it may be 500 volts, 600 volts for can be different. The motor use can have different voltages. What motor is actually used for driving your vehicle in a hybrid vehicle? This may be 300 volt motor, and the generator may be 600 volts, or it can be 200 or 150 or whatever may be. That is what it generates. Current rating will be different. So appropriately convert the voltage from 600 volt to 300 volt, downgrading. That is done by the converter. Similarly, if it is a lesser volt, 200 volt, you want 400 volts, the converter will amplify 200 to 400 volts, supply to electric motor. Correct? So that's how it works. Then finally, the electric motor generates the mechanical torque. T motor, this is T engine. Both will be connected. The output is TE plus TM is going to TW to V. Similar to this one, here it is almost similar to your parallel hybrid. Only the name, you can see that it is called split power. What you are splitting, the power generated by engine is split into drive the generator and produce electrical voltage, charge the battery. From there you do it, and one part goes directly to wheel. This is mechanical direct. Some part of the torque generated by engine will go to generator also. If you want to charge the battery, if I don't want to, if the battery is fully charged, I need not drive this one. My engine torque will directly go. The mode from battery power will come to the electric motor. That power that will go. Correct. So it is similar to parallel hybrid. Almost same. Only thing is in here the torque generated by engine also some part of the power, not full part, will be used for running the generator, which will charge the battery. Please. The solid soft black color is called mechanical power. Correct. Mechanical power generated by motor. Mechanical power is generated by the engine. That mechanical power is split into two parts. That way it called split power. Name. Correct. You understand. Okay. We will see how it works. The split power is become very popular nowadays. Most of the vehicle. The IC engine torque is dependent on the speed. We know that speed torque already talked first class or two classes before. Engine torque, peak torque is only particular RPM, correct? So engine torque is speed dependent. At low speed, torque is very low, correct? This is my 0 to say for example 6000 RPM. At a low speed, you can see a torque will be listen. Even when you go high speed, also after something start drooping, correct? Engine, that is fundamental character. You can't do anything. Engine fundamental characteristic. So low torque is very low, hence requires a gearbox. Generally, we start from 0 RPM, ideal RPM, then you put the gear starting to ideal RPM 600 to 800, 1000, 2000 as plus the accelerator. Engine speed is increasing, then torque increases. Only a particular reason gives. So this is that means we already know about it. Hence, IC engine based vehicle require a bigger engine to overcome the static friction at the accelerated vehicle starting with 0 speed. When I start the vehicle, maximum torque is needed to overcome the static friction on the wheel. That depends upon vehicle weight. Vehicle weight means the empty weight with fuel, with passenger luggages. All together is going to act on the four wheels. Then that is normal force. We say T normal force, Fn, normal force acting downwards, and there's a road friction, and then you are driving your wheel, which has to overcome all these things. Correct? If you are able to generate torque sufficiently, the vehicle will start moving. The vehicle has to generate. Okay. So generally, when the vehicle starts from standstill, that means you start your vehicle, it was neutral, you put in the first gear, then you start accelerating. That time only maximum torque is needed. That means burn from the engine. But engine produces less torque literally because it is a lower speed. Correct? You cannot take your vehicle to full speed and put the clutch. That's what if you're a new learner, correct? Two-wheeler, four-wheeler learner, correct? Many times you do that, correct? So somebody will be sitting next to you, driving your instructor or your friend sitting backside, and you will say, put the gear and release ideal speed. Correct? I'm talking two-wheeler or four-wheeler, 600. So now one thing is without pressing accelerators, you will release the clutch, full clutch. So vehicle will jump and stop. Because there's no torque is available, sufficient torque to overcome the static vehicle stop. You will be doing many times later. Otherwise, your friend or the instructor, sir, don't do it. You have to give more this one. Press the accelerator, then release. What you do? Because you don't know how to control the clutch. So sometimes you will give press full acceleration or partial without the load, engine will be crying. Correct? 6 will make a lot of noise. And of course, the generator, then suddenly you release the clutch. Then vehicle jump and you may go and hit somebody. Correct? So I'm just saying what happens. So that means we need more torque to overcome the static friction. Engine cannot give. That's why you want to go to hybrid vehicle. Okay. However, now you can do that without gearbox. Also, you can do it. For example, initially it means instead of having my car has a 100 kilowatt engine, just IC engine, correct? And without gearbox. This initially the torque generator is not sufficient. Correct? The torque generator is not sufficient. So that means I want 200 Newton meter at low speed itself at 600. That means I can have 300 kilowatt engine. 300 kilowatt engine at even around 2000 RPM can generate more torque. But once the engine vehicle start moving, the static friction is gone. Only aerodynamic friction, rolling friction is there. That are much lesser compared to static friction. So that time you have 300 kilowatt engine. That engine is a bigger engine, weight wise, and you don't need that much power. What you need is 100 kilowatt power at mid torque. That means you put a bigger engine, you can avoid gearbox. But you have bigger engine, you will be wasting too much weight, unnecessarily carrying weight, and that power is not needed for your vehicle. So that's what I'm trying to say. Bigger engine capacity produce more there, but it adds a weight, unnecessarily wasting fuel also. That is why you are forced to use the gearbox. Smaller, whatever is needed at mid throttle condition or full throttle condition, 100 kilowatt sufficient. But the 100 kilowatt engine, whatever it produce, the torque at low speed is not sufficient. That's why you put in gearbox. Gearbox is the added weight, all those things already we saw. So that's why we are going for electric vehicle or hybrid vehicle. Hence, this split power, this one, electric motor IC engine is used. And initially when starting, most of the time electric motor will be powered most. The maximum torque comes from electric motor while starting the vehicle. When low speed, at low speed, the electric motor will be giving maximum torque. So you need not run the engine at low speed, producing more pollution, low fuel efficiency, all those things. Low speed, generally, once vehicle become high speed, cruising condition, all those things, the electric motor power can be reduced considerably, and more power will be coming from engine while vehicle going higher, cruising or high speed in highway. So this is done by automatic control by the vehicle controller, hybrid vehicle controller. This is what the split power cycle we are talking. Correct? Please see that both are working. It is like a parallel hybrid. Both electric motor and this, depending upon condition, the vehicle controller decides whether take more power from the electric motor or more power from the IC engine. It is accordingly the fuel control, battery power, supply to motor, all this will control. So low speed, majority of power will be coming from your electric motor, battery power, and still engine will be there, because many times this kind of vehicle, full power may not be available from the one way. This one, for example, I want 100 kilowatt total power requirement. Maybe the electric motor may be 70 kilowatt, and the engine may be around 30 kilowatts. Right? So because it can be like that. So the combination, that's what the company different company decides whether to have 60 and 40. The combination, which is better, all those things, drive cycles, where you are driving, which country, all those things, because vehicle manufacturer, finally, if you want to sell the motor vehicle in the particular country, they are competing with another manufacturer. Your vehicle should show more fuel efficiency, less pollution. So accordingly, this combination will be worked out, which power should be. But most of the time, both will be working in split power circuit. When you come to the city, low speed, generally more power will be taken from electric motor. That's what I want to do. In split power, a smaller, less flexible, highly efficient engine is, that's why I said 30% or 25% power will be coming from the engine. Remaining power most of the time coming in electric motor. That's what in split power cycle, most of the manufacturer does like this. So the split power, another name is also called series parallel. Correct? I told you this is called series parallel. Why? Because this can be removed, disconnected. From here, power can go like this. That becomes series. We know that engine is running and it drives a driver. The mechanical power directly going to wheel will be stopped. Split power. There's arrangement. Here, clutch arrangement that you can remove. Correct? So the engine will drive generator. Generator will output will be converted to charge and given to the converter. Electric motor, the energy may be stored in the battery, it will go to this one. So it becomes a series hybrid. Correct? So this split power can work as a pure series hybrid or parallel hybrid also. That's what I want to do. Correct? So it can work as that's why it's sometimes called series parallel hybrid also, or another name. Anytime you can make it a pure series or parallel. That's why series parallel. Power split, a series parallel hybrid, drivetrain, two powers already I know, we are not going to talk. Power from both sources can be available. Generally, power splitting using the planetary gears. Somebody was asking in the class beginning how it is done. Correct? Power splitting will be done by planetary gears, where torque can be added or separated. Power split allows either the engine or electric motor alone will drive the vehicle anytime. You can disengage engine and you make only motor will drive, or disengage motor, allow more engine alone, or both together. That is about that advantage of planetary gear arrangement. And it allows both engine and electric motor drive the vehicle parallel combination. Correct? Just as a pure electric vehicle. Correct? Please note that I told you it may produce 70 kilowatts. Correct? And another one may produce a 30 kilowatt or 60 kilowatt and 40. Please say that with the electric motor alone, you may not be able to reach full speed. That you have to remember. Correct? So it gives only, I said my vehicle is 100 kilowatt. If you want, drive your vehicle, say 140 kilometer speed or 160 kilometer maximum speed. Correct? With the full load, 4 passenger, all those things, then both should work. Then only 100 kilowatt will be available. But as I told you, you can cut down one power. For example, 30 kilowatt. That means any given instant, you have only 70 kilowatt. With that, your vehicle will not reach full speed. 4 passenger already sitting, it may go up to 70, 80 kilometer only. Correct? If you are trying to accelerate more than 70, automatically the vehicle controller will start the engine. Correct? Add the engine torque because it is done automatically. That is what is the ECU job. They control the vehicle. Correct? You won't even know that whenever needed, the vehicle controller, correct, split power or series parallel, vehicle controller will automatically switch on or switch off. Which one? The engine, motor, how much power, all this thing done automatically. Correct? This management by ECU. So that means only one is working, you will not. Similarly, if you start using only IC engine, correct? That time the electric motor is off because it is for example 6 years, then you will not be able to drive full speed. That is what. So which combination used, that decided by the company manufacturer. Whether many times better have bigger electric motor compared to IC engine to reduce the carbon emission, all those things. But sometimes you want power, acceleration, all those things. They may have 50-50 also. IC engine 50, this also 50. That's correct. So different combination you can company decides. Okay, power ratio can be 0 to 10% for the combustion engine. Correct. Pure engine or engine alone driving vehicle. In that case, the power from the engine will be 10%. Motor will be off. Electric motor can act as a generator also. Generally, we know we will talk about regenerative braking. Correct. Whenever if you are applying brake, we are going 100 kilometers, suddenly you want to apply brake. Then we apply brake. We know that brake shoes are getting heated up. That means the energy in the vehicle body, which is momentum, correct? Forward momentum, so much kinetic energy there. That energy is dissipated in the brake shoes when you apply more force. So that means that has a big, great, there's a heat is generated, brake shoe will worn out. That is a kinetic unnecessarily you are wasting. In that case, in the hybrid vehicle, one thing what they do is the electric motor, which was driving the vehicle, can become a generator and it will be connected to wheel. Wheel will be driving the electric motor. That time, input power to motor will be cut off and it will become a generator. Then it generates electric power that will be used for charging the battery. That means you are recovering the energy. That is called a regenerative braking. Many of you will be knowing that is another advantage in electric vehicle. Okay, that is possible. So the most popular series parallel type hybrid vehicle is Toyota Prius. It was you know that the name Prius means, correct? It is a Latin word. Prius means first, correct? Say first son, first baby, first something we say, first time. So Toyota put this name. This Latin word Prius meaning means first. Nobody before that hybrid vehicle was not made by anybody. Whether German company, American company, nobody made, only Toyota made. So that's why they put the model name, they call Prius. We are the first to make hybrid vehicle and it is most successful. It is a series parallel hybrid. So this arrangement shows this is the series parallel arrangement of Toyota Prius. You can see that it has 4-cylinder engine and the engine output is connected to a sun gear, planetary gear arrangement, and then it has 2 electric motors, motor 1, MG1 and MG2. Okay, this MG1 can become generator also, correct? It can become generator, both can become this one. This is mainly used for driving. This one is generally for regenerative braking, all those things. And all 3, motor, engine, motor 1, motor 3, all these things are connected and the total torque is supplied to wheels using the planetary gear arrangement. So this is how it works. Okay. Split power, series power. Power split allows vehicle to behave like a series hybrid. Already I talked, to run only with the engine, and simultaneously can charge the battery also. That's why we call it split power. Correct. The engine may be generating 70 kilowatt. Correct, or 50 kilowatt, and it may be used for driving the vehicle at, correct, and some amount of power can be used for charging the battery also. So that means most of the time battery can be kept at fully charged condition when you, because the vehicle will be driven high speed and highway. That time you can charge your battery. When you come inside the city, low speed, and electric motor will kick in, and so the emission can be reduced. Correct. So while electric motor provides driving power to the wheel, and the engine also provides. The splitter allows the internal combustion engine to augment power delivered by electric motor. That's what I showed you. Motor torque is not sufficient, means engine also will kick in, that also will come, but some part of the torque will be for charging the battery. That's why it is called a power splitter. No need for manual or automatic gearbox, as the power splitter device itself, the sun gear arrangement itself, behaves like a variable to CVT, variable continuous variable transmission system. It automatically adjusts the torque and power delivered from engine to this one. You don't need. That is the one advantage of series parallel hybrid circuit engine vehicle, because which has a planetary gear arrangement. The transmission works like a CVT. The eliminate need for separate starter motor, because one of the motor, right? So this motor can act as a, let me clear that. This motor 1 can act as a starter motor also. Start the vehicle and it will become an electric motor. Once it is started, it can supply power, and then the other motor is there, then engine. Correct? All three can work together. The last type is called what you call plug-in hybrid. 4 types you are talking. The plug-in hybrid vehicle, as again, once you say hybrid, definitely there are 2 powers. One is engine, other one. Only thing is the power, no, or the motor and the engine. What is the range? Correct? I need 100 kilowatt. What will be the more electric motor power? What will be engine? That varies depending upon type of this one. Except series. Correct? In series, we know that engine is going to the generator output is going to motor only drives. There is no question of engine driving wheels. That is impossible in series hybrid. Okay. So in plug-in hybrid, why we call plug-in hybrid? You can see here, you have a power connector through which from electrical outlet or grid power. Correct? Electrical grid power will be from the electrical outlet, will be connected to charge the battery. Correct? So this is a traction battery. This will be charged through electrical power from the grid power. And other vehicles, all the other vehicles, batteries charged by engine only. You will not have any connection, electrical power. Okay, so battery will be you charged by this one here. That's what they call plug-in hybrid, in which you have electrical socket through which you charge the battery. Of course, it has an engine also which can charge the battery, but engine capacity very small. It has electric motor which is driven by battery power pack. So that's what going to drive most of the time in plug-in hybrid. It is like a pure electric vehicle. The engine very small capacity, maybe 10 or 15% capacity, mainly used for charging the battery. Okay, when there's no other resources available, you don't have a charging station in between. When you are driving a highway, suddenly the power is dropping. So in that time, automatically engine will kick in and start charging the battery. Please note that in plug-in hybrid, electric motor only drives vehicle. Engine never drives because it is a very small capacity. It is going to charge the battery. Internal combustion engine running with petrol or diesel fuel. Charging the PHU battery from electric grid or standard wallet or by IC engine, because I told you when there's no electrical grid is available to charge your vehicle, in between your battery power is reduced, SOC, state of charge is reduced considerably, the engine will kick in and it will start charging the battery. Normally, vehicle uses power from the electric motor. When the battery power is discharged, it is recommended. It is driven by IC engine also sometimes. Very small, very slow. Please note that with small capacity, we cannot go faster. Many times students ask questions, sir, you said 20 kilowatt or 10 kilowatt engine for 80 kilowatt motor. Whether 10 kilowatt will drive your vehicle, four-wheeler? Yes, it will drive. But the power or torque produced not sufficient. You cannot go high speed. Slowly you can drive. Speed can come down considerably, but still you can drive your vehicle, reach its destination. Correct? So this is a figure is shown here. The plug-in hybrid electric vehicle with a small engine which is called a range extender to extend the range of the vehicle. As I told you, this engine can drive the wheels also, or it can be used for charging the battery. Correct? So in hybridness in the vehicles start from 50 to 10%. Again, I told you. Just now I told you may ask questions, 90% or 80% of power will be coming from vehicle. For example, 100 kilowatt means I may have 80 kilowatt electric motor, 20 kilowatt IC engine. Correct? I may have 70 kilowatt and again 30 kilowatt this one. Please note that this engine power, correct, whether 10 kilowatt, 20 kilowatt, 30 kilowatt, 40, even it can do 50-50 also. That's what I say. Hybrid 50 means 50 kilowatt motor, 50 kilowatt electric IC engine. Both are equal power. Correct? And both can work together, full power. So I can go to maximum speed and acceleration, all those things. But if I wanted to go into city, low speed, I can switch on only motor and engine will be off. In the highway, I am cruising, not with not on the engine. My vehicle speed maximum 120 kilometer. That time only maximum aerodynamic drag, all those things. But I drive a 40-50 kilometer. This engine is sufficient. I can cut off the motor. Correct? That's why in the plug-in hybrid, the hybridness means what it means. Already I told you previous class also. How much power is coming from the electric motor? Whether 10%, 20%, 30%, 50, 70, 100. 100 means pure electric vehicle. It is not hybrid vehicle at all. Correct? So that is what. So the hybridness, that means power. How much percentage of power coming electric motor can vary from 0 to 50. That is hybrid. Also we know that H means electric power divided by total power. Correct? So electric, that's how it is. So it is generally varied. A plug-in hybrid will have large capacity, heavy battery compared to this one. Generally, correct? Nowadays, the modern hybrid vehicle, the electric motor power capacity very high compared to IC engine. Most of this one, it can be up to 50-50 also. Correct? Compared to full hybrid vehicle, no additional equipment to connect the external wall plug, electrical power for this one. Plug-in hybrid needs, correct, wall, correct, to charge the battery. Okay. Need additional equipment to connect this one because charging circuit. This battery, you need a rectifier, all the things. That's what we charge as battery charger. Correct? Electric vehicle nowadays we are coming with charger also. Most of the time we are going with pure electric. Directly have a similar to the plug-in hybrid also need an electric charger, not like a other type of series parallel type of hybrids. Okay, so due to high voltage power packs, charging voltage has to be higher for because many times the plug-in hybrid, the battery pack capacity is 600 volts, lithium ion 400. So that means you need a charger, high voltage charging circuit, quick charger. They call different name will be there. Plug-in will likely to have small gasoline engine driven by generator onboard charging. I told you many times, maybe 10 kilowatt or 10%, 15% can be. Okay, now that we talked about the different type of this last 2-3 classes, series, parallel, power split, and all the plug-in hybrid, we will see practical this one. There now many companies come. I am just going to show 2 or 3. The first one are Toyota Prius. I told you Prius is called first. They only brought first commercial hybrid vehicle, no other company in the world. So that's why they gave the name. 1990 they started. Still, it is very popular. They sold more than 5 million or 10 million, or I don't know. Very big number. They're able to sell throughout the world. No competitor for them as a hybrid is comparatively. Now, new companies are coming, but they are there for. So, the Prius you can see that it has a 4-cylinder engine. Started with petrol engine that time because they want to sell in US. US, you cannot sell diesel car. Nobody will be ready to buy diesel car. In US, petrol price was kept at very low, $1, close to $1 for more than 50 to 60 or 70 years. Correct? Only for last 20, 30 years. Now it has become $4.5. All governments, all presidents for last 100 years after the invention of this one, they try to keep the petrol price within $1, 1 gallon, not 1 liter. 1 gallon, around 3.76 US gallon, will be less than $1. They were able to keep, but now they could not do it. That's okay. That's why they all car will be petrol cars only. No diesel cars, very rare. Because I lived there, I worked there in US for 1 year. I had a car, and if you go to market, diesel will be very, very, very few, maybe 1%, 2%. Car means, including SUV also, generally they will, that time they have petrol engine only. They are not bothered about fuel costs. But now it is not so. Fine. So it has a 4-cylinder gasoline engine, correct? And it is connected to a planetary gear. This is, I know it is a series parallel hybrid, correct? So that way the engine is connected. Yes, please. Hello, Vigneshwaran, can you mic? Somebody call Vigneshwaran, tell him to.
Yeah, sir. I'm calling, sir. So we continue, sir. I'm calling, sir.
Yeah, it is a 4-cylinder engine and it is connected to planetary gear. I will show you this one, the detail this one. And it is connected through planetary gear. It is connected to wheel. Correct? You can see the power, mechanical power directly goes. Okay. And it also connected to a generator. Correct? It also connected to some amount of power. That's what it called split power. So some amount of power will go to generator. Generator produce electrical current that goes to inverter. From inverter, it comes to from inverter, it goes to DC to DC converter. Then it has a nickel battery. Nickel battery was they were had. That time lithium-ion battery was not there. Lithium-ion battery was 15, 20 years. That time it was instead of lead acid battery, they call nickel cadmium nickel metal hydride. NiMH means nickel plus metal hydride battery. That was to 2005 something after the lithium-ion battery came, because this lead acid battery is very poor energy density, right? That was there for last 100 years. After the nickel battery came, then you have lithium-ion, that is Li batteries. So it has a lithium-ion battery power pack, 20 kilowatts, 200 volts for the voltage, and 6.5 ampere over the current rating. It produces 21 kilowatts energy that will be supplied to motor. Correct? You can see that engine from here it goes direct mechanical, and you have electric motor here. It is a parallel hybrid. That means you have planetary gear. Through planetary gear, this is connected. This is also connected. From here, there's a shaft going. Right? Gear reduction and goes to wheel. It is a front wheel driven vehicle. The torque from motor, torque from the engine is coming, and the combined torque is driving wheel through gear reduction. Okay. Some part of the torque from the engine, power from the engine goes to generator. Correct. So that it has inverter, and from inverter it can charge the battery, or it can supply this. So this is what the functional block diagram. Okay. So power electric motor from the engine through this one to wheel, and there's an electric generator. You can see here. Okay. The total power, the combined power available for wheel is 195 to 196 bhp engine. Correct. So that is the power, not engine, power available from both engine come electric motor. It was giving per gallon, miles per gallon. That means 57 miles they were giving, because US units, 1 gallon meant around 3.76 liter petrol. If you fill the vehicle, this particular Prius will go 57 miles. Correct? 57 into 1.6 kilometer. Something close to around 90-95 kilometer per 3.7 liter. Very high, big number that time. And a later model, nowadays, Prius is available, different model. It is also available, not only series parallel, presently it is available as a plug-in hybrid also. It is called Prius Prime and PHV they call it. They are offering different model. Series parallel plug-in, both is available for Prius from Toyota nowadays. That's what I just want to say. This is this one. So how it works, because this is nice, this one. I got it from internet, from this website. Okay. This is a journal paper, research gate journal. They were talking about modeling simulation of this one. You can see here, you have IC engine, as I told. Then it is connected to a planetary gear. It is connected to sun gear of the planet. Planetary gear has ring gear. In center, you have a sun gear by carriers, planetary gear. They are called carrier gears, they call it. Correct? So the sun gear is connected to the engine. Okay. The planetary gear arrangement is connected to this motor 1, MG1. Okay. This can act as a MG means motor cum generator. MG means it can work as a motor. If you need, it become a generator also. Okay. From here, it goes to the converter. From the converter, it goes to battery. It can charge the battery. This MG1 can charge the battery. Then you have the second electric motor. This motor prime job is to drive the wheels. Okay. But please note that this is connected to sun gear. The motor is connected to like engine, because the connected to sun gear. The carrier is connected, the ring gear is connected to wheel. Please see that in the both engine, correct? You have one planetary gear, second planetary gear. The ring gears of both are connected. That means this plus this, correct? This added. Torque from engine, torque from second motor will be added and delivered to the motor, the wheels. Okay. So some amount of power is given to the MG1, goes for charging the battery. Okay. That's how it works. Correct. So you can see the planetary gear arrangement only. It has a power splitter and also as a CVT. Both it does. That is advantage of planetary gear arrangement. Okay. So Toyota, this is actually series parallel, becomes so popular that this particular arrangement, correct, series parallel called Toyota hybrid system, THS. This is also because they are the first introduced to become very popular. Others are also trying to use the same arrangement. Correct. Of course, they would have some royalty sharing. I don't know, maybe something. People are same arrangement trying to introduce it. It uses two synchronous motor. Please note that this I told you, the motors can be DC motor, AC motor. Toyota is using AC motor. It is called synchronous motor. It is not a DC motor. AC motor highly efficient, power losses, electrical power losses are minimal, many advanced, rugged compared to DC motors. Maintenance is very easy. That's why they are using AC synchronous motor and one IC engine. This engine, correct? That these two motors synchronous motors. The driver motor would boost the engine output while acting as a generator during the deceleration to charge the battery. This one they call as a driver motor, correct? This is as this will boost engine output while acting as a generator. So it takes some amount of power from the engine and charges the battery. Okay. The second motor would use a drive power. That means it is like an engine. This power is used for driving the wheels. This is generally used for charging the battery and how it gets power from the engine. That's why it calls split power engine. Correct? Another name. And use this one. Then second motor is also can be used as starter motor. The second motor also can be used as vehicle starter motor. A power split device, which is nothing but planetary gear arrangement. Already I showed two planetary gear would connect the two motors with the engine. Correct. The planetary gear arrangement is used for connecting both the motors to engine, and so total power is given to wheels. That's how it works. The IC engine output would be divided in two parts, as I told you. And one part is driving vehicle, other part is that is done using planetary gear. That's why it is called as split power. This hybrid vehicle is also called split power. Engine power is split for charging, driving a generator. This one. Because we know that this planetary gear can work as a CVT, which will also use for controlling the speed of the engine. The inverter would be placed in between the battery and the motor to convert current between direct current battery to AC, synchronous motor. Correct? I told you here. You can see that inverter. Correct? Battery power is a DC voltage. The motor, this motor is a AC motors, synchronous motor. So that means by the generator, this one, that will be converted to AC, given to motor. That's what we are talking. Correct? So both the motor synchronous AC motor, battery back is a DC. So DC voltage should be converted to AC, and voltage can be increased. This is 200 volts. They have not mentioned what is the voltage rating of these motors. Two synchronous motor with a 400 volts, 600 volts, 300. So appropriate voltage will be converted to AC. AC will be increased to given to wheels. Okay, the hybrid is how it works. That's what it connects. This also again I took it from net. Beautiful, colorful, neatly they're given. How it works. This is a Toyota hybrid system. Prius only. Correct. You can see that you have the engine, 4-cylinder engine. The engine shaft is connected to the planetary gear arrangement. Correct. This is the planetary gear arrangement. You can see that the whole thing is planetary gear arrangement. Okay. This is called sun gear. Correct. Main gear, sun gear. Correct. And then the outer, correct. This is called ring gear. Ring gear is connected to driving the motor and also to the wheels. Okay. So this is the second motor. This is MG2. This is MG1. MG1, it can work as a, here it is shown as generator. We are going to charge the battery, and it can also work as a motor and provide additional torque. This can work as a motor also and also generator. And when it works as a generator, it gets the mechanical power and drives the produce electricity to charge the battery. It can get the electrical power from the same battery pack, and it can work as a motor. Okay, so this is how it works, the sun gear arrangement. Okay, this is for information. I am not going to ask you to draw the exact figure. You can say that the power is given to from engine power or motor power given to sun gear. These two are called planetary gears. The outer one is ring gear. Ring gear is connected to the wheels. Correct? To this gear is ring gear. This is ring gear. Blue one is ring gear of the planetary gear. That is connected to another gears. Correct? Power reduction or this one, and connected to wheels. Okay. So main shaft power is coming from the engine. They go to sun gear. Planetary gear is connected to this generator. Right? So you can see that power from this motor is connected to the ring gear. Okay. And then the generator is connected to sun gear. From the sun gear, this gets the power. So some power is coming from motor, the engine, torque, some more power directly from this. So both are clubbed, and this is going to wheels. And some amount of torque generated by engine is split here and goes to generator to charge the battery. Correct? So that's why we call split power hybrid. This is what the Prius. This is used by many people. So same arrangement. No, okay. Next one is I'm giving. There are many hybrid vehicles. I am not going to. I took few. The power train layout of the Honda Civic. Correct. You can see that you have an engine. Then you have an electric motor. The electric motor is driven by this battery, and there's an inverter from battery. This is DC voltage. Inverter makes it as a AC voltage. Automatically, this motor has to be a AC motor. Correct. That means the Honda Civic is a AC motor, not a DC motor. Whenever you see an inverter, automatically you can understand that the motor is an AC motor. If they are from battery, there's an inverter. From there, it goes to a motor, means that motor is AC motor. And there's this one. Together, they produce the transmission. That means by this one drives the wheel. The Honda Civic hybrid is electric motor mounted between IC engine CVT. Correct? This is CVT transmission. It is engine, electric motor, and CVT. So this is connected between this one. The electric motor either provide assistance to the engine during power demand or splits the engine power during the low power demand. So that means when power is not needed, what it is saying is engine produces torque TE, the electric motor also produce TM. Both can be added and given to this CVT and vehicle. That means when you are full throttle, you want to go to full speed, maximum speed, correct? That time the engine torque alone is not sufficient. Then motor torque will be combined and both will be driving the vehicle. Suppose if you are driving a slow speed, you don't need that much power coming from the engine. What will happen? The engine will become a generator, correct? The motor will become a generator, takes some amount of power and converts and charges the battery, correct? So that's why it calls split power. This is Honda Civic. Ford Escape, because not only that, Ford also making a hybrid vehicle. Again, you can see that uses a hybrid concept similar to Toyota, correct? You have an engine, you have electric motor one connected to the engine, exactly same configuration, correct? Then this is the planetary gear arrangement, correct? This is second motor that also connected to both engine and motor 2 are going to drive the vehicle. These two are drivers, correct? How much? This motor can be a driver. It can become a driver, add power to this, or it can charge the battery, driving the generator, become a generator, correct? It becomes a generator, charges the battery, correct? So it is similar to what we saw the previous. Okay, I think I'll stop here. We saw different type this one. Few more slides, how it can work. Next class, we see benefits, all those things. Then we will dig into the how to design, power requirement, calculation, something like that, more on it. So next class, I will close this arrangement, this hybrid class, correct? What are the different modes it can work, operating on hybrid vehicles, and what is the advantages, benefits, limitations, and because of the limitations, the electric vehicles were stopped, or hybrid vehicles were also stopped. Then later, EVs came, hybrid vehicle. Then EVs also we'll see in next class on Monday.
Sir?
Yeah.
Monday 5 to 6, Shankaram is not taking. Can you take the? Is it possible to take one 5 to 6?
5 to 6 I will take, 6 you can go back.
No. We will have another class.
Another class.
Sorry.
Oh, sorry. Okay, sorry. Okay. We will have it 6 to 7 only, sir.
6 to 7. Okay. See you on Monday 6 to 7. Give your attendance before leaving. Have a nice weekend.
Thank you.
See you on Monday.
Sure,
6
sir.
o'clock. Thank you.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you. Take care. Have a nice weekend.